Today's lesson is on frequency tables and two-way frequency tables. Once again, the vocabulary is listed at the beginning of the lesson. Please review it as you study. Before we begin this lesson, we need to review converting fractions into decimals and percents. Let's use these examples. A fraction is a division problem. 3/10 is 3 divided by 10. This gives us 0.3. This makes sense because tenths are the first place after the decimal point. So we could have just written 3 and moved the decimal point back one place. To convert 0.3 into a percent, move the decimal point 2 places to the right for 30%. 1/4 is 1 divided by 4. This gives us 0.25. To convert the decimal into a percent, move the decimal point 2 places to the right for 25%. 1 is the same as 1.0. To convert 1 into a percent, move the decimal point 2 places to the right for 100%. Thus 1 is the same as 100%. 23/1000ths is 23 divided by 1000, but the easier way to get this is to remember that the thousandths place is 3 places to the right of the decimal point. So write 23 and put the decimal point 3 places to the left of the end of the number. To convert this into a percent, move the decimal place to the right 2 places for 2.3%. 29/40ths is 29 divided by 40. This gives us 0.725. To convert this into a percentage, move the decimal point 2 places to the right for 72.5%. 3/2000ths is 3 divided by 2000. Let's try the calculator for this one. 3 divided by 2000 gives us 0.0015. To convert this to a percentage, move the decimal point 2 places to the right for 0.15%. 9/20ths is 9 divided by 20. Once again, let's use the calculator. 9 divided by 20 is 0.45. To find the percentage, move the decimal point 2 places to the right for 45%. 20/30ths is 20 divided by 30. I could also divide 2 by 3 since the equivalent fraction is 2/3. 2 divided by 3 or 20 divided by 30 give the same answer since they are equivalent fractions. 0.6 repeating. To convert this decimal to a percent, move the decimal point over 2 places for 66.67%, rounded to the hundredths place. 7/25ths is 7 divided by 25. This gives us 0.28. To convert this into a percentage, move the decimal point 2 places to the right for 28%. 30/25ths is 30 divided by 25. Since the numerator is larger, this number will be greater than 1. 30 divided by 25 is 1.2. To make this a percent, move the decimal point over 2 places for 120%. Now that we have practiced converting fractions to percents, let's create some frequency tables. This first example is a one-way frequency table. I asked a class of 30 students whether they preferred as pets dogs, cats, or some other type of pet. In this class, 26 students preferred dogs, 3 preferred cats, and 1 preferred another type of pet, for a total of 30 students. This is a one-way frequency table. The numbers in the row add up to the total of 30. In a two-way frequency table, there are 2 sets of variables. I still have the pet preferences along the top, but on the side, I've divided the class into girls and boys. This way, I can compare the preferences of the girls and the boys. In this class, there were 15 girls who preferred dogs, 1 girl who preferred cats, and no girls preferred another type of pet, for a total of 16 girls in the class. There were 11 boys who preferred dogs, 2 boys who preferred cats, and 1 boy who preferred another pet, for a total of 14 boys in the class. The overall totals were the same as before. There were 26 students who preferred dogs, 3 students who preferred cats, and 1 student who preferred another type of pet, for a total of 30 students in the class. To check the table, make sure that the rows add up to the right edge. Make sure that the columns add up to the bottom edge. The numbers in the center of the table are called joint frequencies. The numbers on the edge of the table are called marginal frequencies. The number in the corner is the total. The reason we make a two-way frequency table is to answer certain types of questions about the data. The answer to the first type of question will be a joint relative frequency. This answer will be a fraction whose denominator is the total and whose numerator is a joint frequency. For example, what is the chance that a person in this class is a girl who prefers dogs? The numerator will be 15, the denominator will be 30. 15 divided by 30 gives us 0.5, which is 50%. What is the chance that a person in this class is a boy who prefers dogs? Once again, the denominator is 30, but this time the numerator is 11. 11 divided by 30 is 0.36, repeating, which converts to 36.67%. The answer to the second type of question will be a marginal relative frequency. This answer will be a fraction whose numerator is a marginal frequency and whose denominator is the total. For example, what is the chance that someone in this class is a girl? The numerator is 16 and the denominator is 30. 16 divided by 30 is 0.53, repeating, or 53.33%. What is the chance that someone in this class prefers dogs? In this case, the numerator is 26 and the denominator is 30. 26 divided by 30 is 0.86, repeating, or 86.67%. The answer to the third type of question will be a conditional relative frequency. This answer will be a fraction whose numerator is a joint frequency and whose denominator is a marginal frequency. For example, given that a person in this class is a girl, what is the chance that she prefers dogs? The denominator comes from the phrase given. It's the total of girls, or 16. The question will be answered in the same row as the denominator. Girls who prefer dogs is 15. 15 divided by 16 is 0.9375, or 93.75%. Given that a person prefers dogs, what is the chance that the person is a girl? Once again, the denominator comes from the given. Look for the total of people who prefer dogs. The denominator is 26. The numerator will come from that column. What is the chance that the person is a girl? So girls in that column is 15. 15 divided by 26 is 0.57692, or 57.69%. Thank you for your attention. Please refer back to these notes as you complete your homework.